For our last unit of geometry, I decided what would be best for the class is to kind of go back to some topics in Algebra 1 that the Algebra 2 teachers do assume you know and will include in your summer homework. So this first screen, I just showed you pretty much our schedule of our videos, and to be prepared for two quizzes, one on May 25th and one on June 1st. So today our focus is going to be solving systems of equations, and today we are only going to solve them by substitution. I'm going to do one just basic problem, and then I'm going to look at two word problems and give you a chance to try a problem on your own as well. When you use substitution, you really want to use it in specific situations. You could use it all the time, to be honest, but you really use it when you can easily solve one of the two equations for a variable. And just to kind of jog your memory a little bit, since this is our first video, a system of equations are two equations with two different variables, and you have several strategies to use to find them. Now, with systems, you can either have one solution, no solutions, or infinite solutions. My goal through this week is not to worry about the no solutions and the infinite solutions. I want to look at the one solutions in terms of real-life problems and word problem applications. So my first question is a pretty simple question. Not too bad, just basic question. I want to highlight that it's from the website purplemath.com, and as you guys go into Algebra 2, if there's anything from Algebra you're unsure of and you're not sure where to go, Purple Math does a really nice job of taking problems and doing step-by-step instructions. So it's a great reminder. So looking at the system that we have two equations. And when I look at the second equation, what stands out to me is that y has no coefficient. Just as a reminder, coefficient is the number that would be in front of a variable. Because of that, that makes that equation, that second one, easy to get a variable isolated. So I subtracted 4x from both sides, and I came up with this equation. Y equals negative 4x plus 24. Since it's called substitution, our next logical step is the substitute. So I took the equation I solved, and I plugged it in to the first equation. So I took out y, and I put in negative 4x plus 24. Now, do be careful when you're doing this problem. We do have a negative 3 times a negative 4x, so be very careful of your signs. Typically with substitution, that's where students will go wrong. So since we have one variable, I just solved it like a multi-step equation that you guys have seen before. I combine my like terms in the next step. So I move together my variables, move together my numbers, divided to find that x equals 5. Now in a system, we already said there are two variables. So I found the first, and since there's no specific directions here, typically what they're trying to find is what is the solution. So once I find that x equals 5, I can choose any of the two equations to plug in the x value for. You know me, I like to work smart, not hard. So I prefer the second equation. It's a lot easier, cleaner to solve, especially because y does not have a coefficient. What I do want you to notice is I did not plug in 5 to the modified equation in step 1, the one that I'm pointing to right here. Why I didn't do that is if there was a mistake here, I would start to notice if something didn't match up, it would give me a place to go. So I substitute that in. I follow order of operations, so I multiply, and then I subtract, and the value of y is 4. Now you're probably wondering, well, you already got the answer. Why is there step 4? You know me, I'm a math teacher. I want to make sure that you check your work and show your work. So for this specific problem, I just wanted to demonstrate how you check your system. Just like with an equation, there is no mystery about if you are right or wrong. So in this problem, I went through and I showed why I was right. I may not write this each time, but it does get checked, and I'll even tell you in one of the problems, I actually was wrong the first time I solved, just a silly mistake, and if I hadn't checked, I wouldn't have known. Problem number 2, we're going to take a look at a word problem, and our word problem has a geometry tie. So if we take a look at the word problem, it tells us that a rectangular garden has a length that is 4 times the width. If the perimeter of the garden is 200 feet squared, what is the length? First things first, this problem is asking for one specific variable, the length. Before I even start solving, and before I start solving, I have to write an equation. Before I write an equation, I have to find my variables. So we already know we're finding the length, so that's a pretty easy variable to find. But we do also know information about the width because we know that there's an equation to write from the first sentence, and we know that in the second equation, or excuse me, the second sentence, we're discussing the perimeter. So once we know we're using length and width, I've decided to use L and W as my variables. For step 2, we actually can write the equations. Typically, these equations are hidden in a sentence at a time. So in the first problem, or excuse me, the first sentence, it says that the length is 4 times the width. Easy equation to write. L equals 4W. Algebraic representation of that sentence. For the next equation, you can actually write this a number of ways. You could write length plus width equals 200. However, I tend to make silly mistakes, and I actually did make a silly mistake on this problem that I'll share. So keeping the equation simple like that and more compact is better for me. But if you write it the other way, not a big deal. This problem is actually a little bit easier than the other problem because the first equation already has a variable isolated. I don't have to get a variable by itself. So what I did next is I plugged in, I put my, multiplied the numbers, I combined my like terms, and the width equals 20. When I first solved this equation, I did make a mistake, so it was really good that I went back at the very end and checked. Now the question doesn't ask for the width, it asks for the length. But once I know the width, I can find the length. It really doesn't matter what equation I plug into, but in my opinion, why you wouldn't choose the first, I don't know. I would just go ahead and do 4 times the width, which is 20, and I find that the length is 80. Now, while I didn't have my work typed up here, although I probably should have because this is the equation that I made a mistake on, it's really important to check because what happened was I found 2 values that worked in this first equation, but when I plugged it into the second equation, I got something like 110. So I made a mistake in there. Checking is important. You'll know that you're right. For the next problem, it's kind of similar, and it actually does deal a little bit more with a little bit of geometry. So it says that a farmer grows only wheat and corn on a 420-acre farm. He wants to plant 200 more acres of corn than of wheat. How many acres of each crop does he need to plant? Step 1, variables. So the question asks about how many acres of each crop, then that means it's got to be wheat and corn. So those are the equations I write. The first sentence gives us our first equation, and this is usually what most students get confused by. If he only grows wheat and corn, then that means the corn and the wheat together is 420 acres. So sometimes when you get a little confused and you're like, I'm not really sure what equation to write, it could be right in front of you. Wheat and corn, W plus C or C plus W. Now the second equation is in the second sentence. He wants to plant 200 more acres of corn than of wheat. A lot of students get this backwards. Let me just show you this real quick here. A lot of us say it the other way. We think that wheat is 200 plus corn. But I would just make sure you keep in mind, what does he want more of? He wants more corn. So those would be the equations we write. Again, I can just substitute this in pretty easily because it's already solved for one of the variables. So I found out that he needs 110 acres of wheat. So if I plug it back in, and again, I think it's easier to choose this equation, although both of these equations are pretty nice. You can go in and find the last value. Now I know I went through this equation quickly, but through these videos I would expect by the third one, once we've set up the equations, you would pause and take a look. In typical Sturgell form, I am leaving you with a question to try. So here is the question that I have for you to try on your own, and when we come to class tomorrow, we'll take a look at this problem and see if you wrote the proper equations. Just as a little aside, a problem very similar to this showed up on one of your algebra tests last year.